The goal in this video is to be able to add and subtract polynomials. But before we do that, we have some vocab to start with for this chapter. The first word is, well, what is this word here? What does polynomial mean? So let's go ahead and start with polynomial. So polynomial is when you have one or more terms that are added or subtracted together such that the coefficients, so this is a coefficient right here, the number in front of the variable here, are real numbers, and the exponent, so the number that's here, is a whole number. So 0, 1, 2, 3, 4. So if something has a negative exponent, it might not be a polynomial. Okay, so it's unless when you bring the negative up, then it makes it positive, different story. So can't have any variables in the denominator. So here's three. All of these are called polynomials. All of these are examples of polynomials. Okay, so it's kind of like the word people. We're all people. Everyone in this class, I could say that we're all people, right? Well, then some of us are girls, some of us are guys, and so on. So we have more specific. So think of this as the broader word, and then we have more specific words. So the next word is called a monomial. So a monomial is a polynomial that's just all by itself. It has one term. So here's an example right here. Another example would be 5. Another example would be 2x. It's just all by itself. Okay, it's called a monomial. Then we can call one of these a binomial, so just a more specific word, if it has two terms. So 1, 2. So here's another example. X plus 1. That's a binomial. Here's another example. 5x cubed plus x. That's a binomial. It only has two terms. Okay, and then lastly we have a trinomial. So a trinomial has 3 terms. Okay, so I remember because it starts with BI for bike, and a bike has 2 wheels, so that's how I remember binomial means 2. So trinomial means 3. So 1, 2, 3. Okay, so the importance of these words are so that way why is it so important to know these words is because they're going to be used in the math world. We're going to use it in this chapter. And when I say later on, when we do section 6.6, so we're on 6.3 right now, we're going to learn how to factor trinomials. You already know right now what a trinomial is. It means we're going to have 3 terms. Then later on in section 6.7, we're going to learn about binomials, how to factor. So now you know in 6.7, they're going to have 2 terms. The problems will look like this. So it's just knowing these words are just going to help you understand when you hear things being said or when you read a math textbook. Okay. So again, all of these are polynomials, just like we're all people, and these are just more, so polynomial again is the broad word, and these are more specific. So now what if something has 4 terms? If something has 4 terms, then it wouldn't be either of these 3 words. We would just call it a polynomial. Okay. All right. Next thing, we've kind of talked about this already, is standard form. And standard form is the way that we write our answers so that everyone's looks the same. So we're going to write a polynomial with terms in descending order. So what that means is we're going to go from the highest to the lowest exponent. So if you look at this example here, these both have x's. But why did I put this one first? It's because of the exponent. So we always go highest exponent to lowest. And so the constant is always last. So the constant is last. Why? Because that's what we decided. So that way we have order. And then it's always in alphabetical order. So an X would come before a Y and so on. Alphabetical order. Okay, so all of these here are in standard form. So highest exponent to lowest, and they're all in alphabetical order. So like, actually none of these have multiple letters, but later on you'll see that we write them in alphabetical order if there's more than one letter variable. Okay, the next word that we need to know is the word degree. So a degree, I think of it like when I write the temperature outside, it's 90 degrees Fahrenheit, right? This is the degree symbol. Well, in math, the degree is just like this, looks like an exponent when we write 90 degrees Fahrenheit, the temperature outside. That's how I remember that the degree represents the exponent. It is the highest exponent in the polynomial. So it's the exponent of the term with the highest exponent. Okay, so now depending on what the highest exponent is in your polynomial, we have a special name for its graph. So if you, and we graphed this last chapter, y equals mx plus b. So if the highest exponent's a 1, it's called linear, right? It looks like the word line. It makes a line when we graph it. When the highest exponent is 2, so for example, y equals 3x squared. So when the highest exponent's 2, we call it a quadratic function. Okay? When the highest exponent is a 3, we call it a cubic function. When the highest exponent is a 4, we can call it a quartic. It kind of looks like the word quarter. That's how I remember. Quartic means highest exponent's 4. And then if its highest exponent is a 5, so when the highest exponent's a 5, we can call it a quintic function. And then anything higher than that, we don't learn a special word for it. We would just call it an nth degree. So for example, if I gave you this this function or equation here and I said y equals 6x to the 9th, we don't have a special name for this. We would just call it a 9th, because the highest exponent's a 9, a 9th degree function. Now, why is the highest exponent? Why do we learn this word degree? Why is it so important? Well, it tells us a lot about the graph. So if the highest exponent in the equation in the function we're graphing is even, the ends, so like think of it as like the arrows right here, the ends of the graph go in the same direction. So if you look here, the highest exponent here is even. So the ends of the graph both go the same way. Same thing here, the highest exponent is even. So the ends of the graph go the same way. Whereas if the highest exponent is odd, so again, just to review, even is 2, 4, 6, 8, 10, right? If the exponent is one of these, the highest exponent in the problem is one of these, then the ends go the same way. Whereas if it's an odd number, so odd is 1, 3, 5, 7, 9, etc. If it's an odd number, so like this one is odd, so if it's an odd degree, the ends of the graph go in opposite directions. So how I make that easy for myself to remember is opposite and odd both start with an O. So when it's odd, the arrows, the ends of the graph, end up going opposite directions. Okay? And so again, I know that by looking at the highest exponent in this one. This is a linear equation, y equals mx plus b, and the highest exponent is 1. Okay, so that helps me when I graph. When I graph and I look at the function's equation, I could just look at it and already know what way the arrows are going to go, whether they're going to go opposite or in the same direction. Now, what we're going to talk about next is how do we know if the function goes up or if they're going to go down? Like, what determines that? Okay, so we're going to write this down, but if you look at this one goes up, and notice there is no negative in the front. It goes up. This one has a negative in the front, and you will notice that the function goes down. So if you graph a bunch of different functions where there's a negative leading coefficient, negative in the front when it's in standard form, then the graph will open down. When it's positive in the front and it's odd, the graph goes from the left to the right. It goes up, upward. Whereas when there's a negative in the front from the left to the right, the graph goes down. Okay, so let's go ahead and write that down. So when the leading coefficient, so remember that just means fancy way for saying the number in front when it's in standard form, in front of the variable. It's the number in front of the variable with the highest exponent. Okay. And this is only if we're talking about a single variable polynomial. So in other words, we're not talking about something like this, where it has multiple variables. So we're just talking about if the equation just looks like maybe something like this, where it just has a single variable in the equation, like x's only or y's only. Okay, so if the leading coefficient is positive, then it goes up. So from the left to the right, it goes upward. If it's negative, the leading coefficient, the graph will go downwards. So again, from the left to the right, it goes down. So again, leading coefficient, if you want to give yourself an example, would be like this. The number in the front here, when it's negative, it opens down and goes downward. Okay, so let's go ahead and practice this vocab now. So I would pause the video and try out these problems here, and then push play and check your answers. Okay, so now that you've tried the problems, let's go ahead and go over them. So the first thing is it wants you to write this in standard form. So I'm going to take the one with the highest exponent. That goes first. Then the negative 3x squared. And then the 6. Okay, so again, that's called standard form. Then it asks you how many terms. So 1, 2, 3. So it has 3 terms. And then it wants me to classify it by its terms. So since it has 3 terms, we call that a trinomial. So trinomial. And then it wants to know the degree. So I remember what degree means. The highest exponent when it's in standard form. So the highest exponent here is 4. So the degree is 4. And because the degree is 4, we call that a quartic function. So quartic. And the leading coefficient is that number in the front when it's in standard form. Okay, the next one in standard form would be negative 8x squared, and this is a positive 5, so we put plus 5. So that means there are 2 terms, and we can call that a binomial. The degree means the highest exponent, which is 2. So because the highest exponent's 2, we can call that a quadratic. And the leading coefficient is that number in the front, so negative 8. All right, lastly, b cubed would go first, then negative 5b squared, and then 2b. So that would be 3 terms, and so we call that a trinomial. The degree, the highest exponent, is 3, so we call that a cubic function. And the leading coefficient, there is no number here, so what number can I put next to any variable and it doesn't affect it? That would be a 1. So 1 times anything is itself. So the leading coefficient is a 1. Okay, now that we've learned stuff about leading coefficient and degree, let's see if you understand how you can use that if you had a multiple choice test and we wanted to see if we could figure out which graph it is using what we know about the degree and leading coefficient. So I would pause the video and see if you know, given this equation here, which is the correct graph. All right, so now that you've thought about it yourself, let's go ahead and check in here. So first of all, because the highest exponent here is even, so since the degree is 4, we know that the ends of the graphs go the same way. So ends go the same way. So the arrows, okay? Then the leading coefficient, the number in the front, is positive. So because I'm going to put LC for leading coefficient. Since it's positive, then we know it goes upwards. So the arrows will go up. So we know they go the same way, and we know that they go up. So therefore, we know it can't be this one. This one they don't go the same way, so we know it can't be that one. Same thing, they don't go the same way. Therefore, it has to be A. Now, if I forgot this stuff, right? There's so much to remember, right? If I forgot what these two numbers do in the function, how could I figure out which graph that is? Well, that's what we learned last chapter. We learned how to graph using a table, or maybe there were two choices that both go up and we wanted to know which one to pick. You can create a table and plug in numbers. And so, for example, let's say I plugged in a 1. I'm going to plug in a 1. If I plug in a 1 for x here, I'd have 5 minus 3, so that's 2, and 2 plus 2 is 4, so I would get 4. So I'd make a table, and then if I go to 1 here, and I go, this is 3, it goes to 4 here. Whereas this problem here doesn't go to 4, this doesn't go to 4 right here, and this one does. So then I'd be left with these two, and I'd continue to make a table to figure out which graph is the correct graph for that equation, if I didn't know this stuff or couldn't use it to help me narrow it down. Okay, so let's go ahead and look at number 5. So here we could see that the highest exponent's 3, which is odd. Whoops. So since the degree is odd, it's 3, that means the ends go opposite. Then since the number in the front is negative, so the leading coefficient is negative, it goes downwards. So we need to find a graph that the ends go opposite ways. So this one does, these don't, so we know it can't be those two. And from the left to the right, it should go down. So from the left to the right, think about it like if you connected them. See how it goes down from left to right, whereas this one goes upward? So that's how I know it can't be any of these, and it has to be A, or I can make a table to check it.